This is my attempt at writing Pac-Man for the Commodore 64. I never owned one back in the day, so after I recently brought a system as a restoration project, and as usual I had to play around in the BASIC, I really liked how easy it was to get sprites working on the screen. So I set myself a lockdown challenge to write a version of Pac-Man. I chose this because I've written a version before using Arduino and the Gameinternals 3X platform, so I had a basic understanding of how the game mechanics worked, and I'd already pulled all the game graphics out of MAME. If you want to learn more about how the original arcade game worked, take a look at Gameinternals.com, Understanding Pac-Man Ghost Behavior. It's a really good website. And also, what brought Pac-Man to game design on YouTube. I'll put links in the description. Okay, so let's go back to the very first beginning of my first programs and just how to get a basic sprite on the screen. On the Commodore 64, everything is done with peeks and pokes if you want to access the hardware. So you have to poke some data into a location, then you tell the VIC2 the location of each sprite's data, and the reason that you have locations is because the VIC2 can be changed to different locations within the Commodore's memory. Depending on how much memory you want to use, you can move them around. So you poke the actual sprite data into one location, and then you point the individual sprites to that location, and then there is another poke that turns the sprite on or off, and then there is another poke which sets the position of the screen in the X and the Y. Now, as a beginner, I was realizing that if the X goes over 255, you have to get into high and low addressing. So I decided to keep the maze on the left side of the screen. So that's it. Everything can be done with pokes, just poking into the Commodore's memory. It's really, really easy. So you just have to design your sprite, convert it into bytes, and then using a table for next loop, poke it into the memory, set the position, and there you go. You have a sprite on the screen. So let's just take a look at my very first program. And there we have it, a yellow sprite on the screen. I can't do anything with it. It doesn't move, but it was the beginning of all this. The next stage was I need to give Pac-Man a home. He needs a maze. So using a screen capture from MAME, I was able to get this graphic. And we have the borders, and then we have the areas with the dots. After some time of looking at that screen, I was able to come up with a two-dimensional array. So this doesn't really do anything. It was just the actual array data. Then we start to get to things like changing the background colors. But the next program is taking that simple sprite and then drawing my two-dimensional array in PETSCII. Now this was still very early. I didn't know about PETSCII, so I didn't know how to change the characters that much. I was more into ASCII. So we have our map and we have our sprite, which is just roughly animated, and we're just working out things like how to get keys working. So the Pac-Man isn't really following any rules. I could just move the Pac-Man around the screen. So this is just experimenting with the PETSCII, and we have blocks and dots. So there is the next step. We've taken the PETSCII and we're now drawing that out for the game screen, and we have the Pac-Man sprite on the screen. So this is the next step. We've taken our PETSCII background, we've got the colors for the dots, and we've got the animated Pac-Man sprite over the top. So I was learning things like that there are separate memory areas for drawing on the screen, and then there's one for the color attributes. So again, using simple pokes, you can just change the color of a background cell. It's quite simple and straightforward, and there's like 1,000 points on the screen. So all these things I was learning, and I was really enjoying it. So our next snapshot, we can see that we have a ghost sprite and a Pac-Man sprite. So in this version, we're just getting used to adding more sprites, and now the Pac-Man is actually following the maze and picking up the dots, and the dots are simply just changed to black color from white. Really simple. So my routine for moving the Pac-Man around the maze is just based on that two-dimensional array, and the walls have one value and the dots have a second value. So as we come up to the edge of a wall, it's just checking if the next position is a dot or a wall, and obviously if it's a wall, it will just stop the value from going any higher. So now we're starting to get into the mechanics of the ghost moving through the maze. And you can see the difference in speed of the Pac-Man moving now that the ghost is moving as well. Not sure what the ghost was doing on this version. It's clearly not moving towards the Pac-Man, so it could be that it was just taking random decisions at each junction. So let's look at this version here that says Pac-Man chase works. So I believe on this one, the ghost is now making its way towards the Pac-Man. It certainly looks like it. And what it should do now is just go around that T-junction. So this was still quite early in the movement development. I believe I was checking every junction for every possible direction to go. So it was doing way too many calculations. That's why it's running so slow. The way that the original game works is it uses Pythagoras to triangulate the closest distance between the ghost and its target. And then when you're at a junction, depending on the type of junction that you're at, you calculate the possible exits for that junction. So let's say, for example, we are at this corner. If a ghost is coming in, it can only go out. So there's really no need to do any Pythagoras at that point. We're purely saying when we get to that point, the direction will go down. Likewise, if we're going up, it can only go to the right. So the corner pieces do not need to do anything clever. They just say, I'm going up, I can only go right. I'm going left, I can only go down. So that is all of those junctions just there, that corner just there, just there, just there. Next we have like these T-junctions, and everything is based on the direction that you're coming into them and the direction of the target. So if we're coming to the left, get to this junction just here, we have two possible exits out, to the right or going up. Now, because we have two possibilities, we have to calculate the distance with Pythagoras. So it would triangulate the distance if I was to go right to the target, and then it would triangulate the distance if I was to go up towards the target. And then it would give a value. And the shorter the value, the shorter the distance. So when you're looking to find out which way to go, you would give all the possible exits a value. The lower the value would be the direction. We never want to go back on ourselves, so the backwards value is always set to 999. And then, depending on the number of exits, we would scan through them, sort them in order, and then go and set the direction to the lowest value. This is also the same for any junction that has more than one exit. So whether that's a cross junction or a T. So to calculate the direction, you need to know the direction that the ghost is moving, the number of possible exits, use Pythagoras to calculate the shortest distance, sort them in order, and then set the new direction based on the lowest value. So that is actually quite a lot of calculations to do in BASIC, and clearly we can see that it's just too slow. And I've actually, while showing this on Twitter, somebody recommended that I look at CC65, which is a 6502 compiler that has direct support for the Commodore 64. So that is exactly what I did. I then started to look at CC65, which is what we have here. I could take the same data structures and the same sprite data and reproduce the map. So I took on the challenge of trying out CC65, and I've missed all the steps out, but basically what I've got is this version in BASIC, and then we have a version in CC65 which is pretty much at the same point. So it's got the same graphics, same sprites, same ghost movement. So we have one Vice window running the basic version. We have a second Vice window running the compiled version. You can instantly see the speed difference between basic, compiled, C. This was really exciting, and it made me realize that I was going to be able to actually write a reasonably good game. From here, I wanted to then look at improving the game sprites and the background. And we can see I've got more animation sprites on Pac-Man, and we have a better looking ghost. And the way that I did the ghost was the ghost uses two sprites, the blue for the background and then the white for the eyes. I did this because the eyes animate separately to the ghosts, and then later on we also have to turn the backgrounds off when the eyes go back to the center. So that made sense, but it also reduced the number of overall characters that we can have on the screen. We could only have 3 ghosts and not 4. But that was actually good because I don't think it could have coped with processing for the 4 ghosts. You see there, I just went over a power pill and the ghost has changed color, which is a simple poke command to do that. And it changed mode where the ghost is now gone from wandering around the screen to chasing after the Pac-Man. I then did some searching, and I found a website called SpriteMate, which is for creating sprites on the Commodore. And again, using the files that I ripped out of the main version, I recreated all of the frames for within the game. So we have the animation of the Pac-Man, 2 animations for the ghost, the animations for the eyes to look as they move around the maze. Then we have the animation for when the ghosts change mode to scatter. And that was again why I kept the sprites for the ghosts and the eyes separate to make that easier to change. A couple of fruits which I haven't really used, scores for the bonus, and then the Pac-Man death animation. And you just save this out and you save it as a raw file. I then started to work on routines to load actual assets off a disk, and then I needed ways to actually make up a disk. So this is Virtual Disk Commander. You can create a disk, and then I could just drop the files. So we have the map, the sprites, and the program, and then you can just load that disk up from within Vice. So here we can see our disk and our files. It takes quite a long time to load the files. The routine within CC65, you had to basically load byte by byte and store them into memory. So there it's finished. And now we're uncompressing and moving things around. So this is going to be quite a later version of what we've been seeing. But that was just a demonstration of making a disk with all of the game attributes. So we have our sprites, and then to actually draw the background, I use Magic Paint, which can load in a PNG. This is the game export from MAME, and you can export it as a program, or you can export it as a file or studio, which can be imported into various programs on the Commodore, but it's actually quite a simple layout, and it's stored in the order that the actual Commodore memory is stored. So it has one block for color, one for attributes, and one for the screen data. Okay, so I found the disk that has the earlier programs where I was doing the development for the maps. I was never very good at naming my stuff. It's always Lee. So when you have Lee 1, Lee 2, Lee 3, you're not quite sure what it is. So this is, I believe, loading the image that was saved from Magic Paint. And these are loading files directly off the disk. So that was a Magic Paint image, and you saw that it drew the characters and then it drew the colors. And then we have the actual sprites that were from PAC-MAN. So we've come quite a long way from that original yellow dot and just the basic map. But at the same time, that also meant that our memory usage changed considerably. So that took me quite a while to get my head around how that worked. I brought a copy of the Commodore 64 Programmer's Reference Guide from a friend on Twitter. Using this, I was able to learn how the video bank selection works. And I changed to, I think it was bank 1, which had a very large free bank of memory that I could use. But unfortunately, that was at the expense of not actually having any default character sets, which is why there's no text on the side of the screen. But I did have lots of free memory to store the picture and the sprites. I still didn't really fully understand everything that I was doing, so I would run into problems with sprites would get corrupted, couldn't work it out, and it was because programs were getting overlapped. But using the bank changing, I was able to get everything in. I eventually figured it all out and had a routine in the compiler where I would just set up variables, and I could say bank 1, and it would automatically reconfigure everything to change the banks. So this version of the game uses the joystick. It has the full ghost AI, so the ghost will follow through the maze, and they change when you go over the power pill, and they change the blue, and they change the way that they move around. So this was quite a development in the game. I also increased the performance by optimizing the ghost chase routine so that it wasn't doing as many calculations on each move. So we're progressing along nicely. I was not so happy with how long it was taking to load game assets in, but it worked, and I could manage it with the disk images. This was maybe like a month and a half of going from the simple yellow dot to this version in CC65. But then I found 8-Bit Workshop now included support for Commodore. So I started to look at that. So this is 8-Bit Workshop, and I pulled all the code over from CC65, and it didn't take too much work, but I was able to get the basics to run, and again did some speed comparisons and found 8-Bit Workshop was even faster than the version of CC65 that I was using. So now that we've got this open, we can see some of the data structures, and there was a couple of things that 8-Bit Workshop couldn't do. And one of them was actually loading game assets. At the time, and this is still a very early version of Commodore support within 8-Bit Workshop, so it didn't include loading files. So I had to include all of the game assets as data. And you can see that there is a lot of data. This is the same 2D map that we had for the actual map structure. 160 is a wall, 46 is a dot, 47 is a power pill, and 0 doesn't draw a dot. So that is how the actual game structure is laid out in memory. So to get this data out of our sprite mate or any of the other tools, I found two programs. One of them is HXD. So here we can load the binary image of the map. And if we export this, we can export it to these file structures. So if I save it as C, we've already done that, 700c.map. And now if we look at it in Notepad++, we can see that it's laid it out in a way that can simply be copied into 8-Bit Workshop. And then you just paste it in. And you store it as a large string with 1,000 positions, which is the same size as the memory. And that is the data for the sprites. So instead of loading them from disk, which we were doing before, the actual files are embedded into the program itself, which takes up more memory, but it loads so much quicker. So now that I was working out how to do all of this, I decided to recreate the map using redefinable characters. So I found another program, which is vchar64. And in here, we have our pet ski, and then we have our tile set, and eventually we save the map. So if we click on our tile set, you can see the shape of the tiles, and then you just go through there and lay them out on the screen. This then generates two files. One of them is the actual tile set, the custom characters. Because we're using Memory Bank 1, it doesn't have its own character set. So normally you have to copy that over from the default bank. So I redesigned them. I also changed the characters so that they look like the Namco font set, and laid out the maps. So this is the screen that we load in. We also have the text on the screen and the lives. And then in-game, to turn the dots on and off or to change the high scores, we just poke the color memory to turn them on or off and change the color of the dots. So this is like the version of where I am at the moment. I'm just going to turn the sound off. I made an intro screen. We're loading the screen with the characters that I designed, and we're just changing the screen colors. There's a routine that flashes the screen color on and off for the power pills. We have a red attribute for fire. So that was the next progression, that really slow loading file from Magic Paint, and then doing the user definable characters, which was a lot quicker. And it also meant that because they're stored in memory, we can flick between the intro screen and the game map. So this is all good. I've got the game working, we've got the ghost following us around, optimized the actual ghost chasing routine. The next part was getting sound working, and I have to say that the sound working was the part that I was least looking forward to. I'd never done any sound programming before, so it was quite daunting. So we have a couple of programs in Vice where I was learning how the music worked, and again it's just poking into the SID address. that was really, really rough, but it was the basics. I did some searching. I found a program called Goat Tracker, which is a tracker. And I spent a bit of time and worked out how to get the notes in and how to set up an instrument that kind of sounded like Pac-Man. So you can hear that sounds a lot better than the first version that I did. I then wrote a program in BASIC which would read in the output file from the Goat Tracker and made a simple version of a tracker player to get an understanding of how these things work. You could hear that it was a lot slower, but I got the basics working. So now we're moving on, and I've got that into, this would have been CC65. So that sounds a bit better than it should do, and I was reasonably happy, but there's no sound effects in the game. So the next step was to recreate the Waka Waka. So I believe that there is, a snapshot called Waka Waka. So let's have a listen to this. That was 3 or 4 days of work to get something running that sounded like that. It drove me crazy. So this is the current version in 8-Bit Workshop. So we have the sound, we have the Waka Waka. And we have the Pac-Man death sounds. So they're all the sound effects that I've got so far. I really didn't like doing the sound effects, so I haven't done any more. Plus, it's quite a lot of processing, and I can't use interrupts in the compiled C. So I can't have an interrupt-driven sound routine running that would allow us to do the sound effects all the time. We're missing the woo 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 noise, and also the noise when the ghosts change into scatter mode. So I'm reasonably happy with all of that. Anyway, there's still a few little bugs in the code depending on the mode that the ghosts are in. But we can see most of the game fundamentals are there. They go back to the home. The bonus points increase when we capture the ghosts. When the ghosts are in patrol mode, the red one goes around this bottom section. The green one goes around the top section, and then the last one goes around the middle. And that's really as far as I've got. So it was quite a considerable learning experience going from those first stages up to where I am now, and I had lots of help along the way. So a big thank you to everybody that helped me when I was posting these on Twitter. I'm really happy with how this turned out, and it's actually quite enjoyable to play. I don't really have any game progressing at the moment. It's the same level over and over, so it's quite easy to actually play it. But the game is fully playable, and I do actually quite enjoy playing it. So there's quite a few things that I haven't done in this compared to the original. So the Pac-Man doesn't cut the corners. You can't change the speed the Pac-Man moves by a small amount. So in the original, as the game progresses, the first level the Pac-Man runs 105% or something like that, faster than the ghosts do. And then the next levels, he runs slightly slower. As the game increases, the speed of the ghosts also increase. Loads of small little details that I haven't put in. But I wasn't going to try and recreate an arcade perfect version of Pac-Man. It was just me learning how to program the Commodore 64 with an interesting project in mind. And this was certainly interesting. I learned so much about how the Commodore works and also pushing what I could do as a programmer. I'm very much a casual programmer. I did spend a few years writing in C many years ago on 286's DOS machines. It was okay. I was kind of self-taught, and the guy that was teaching me at the time wasn't a particularly good teacher. He would kind of give me some help and then moan at me when I didn't do something to his standard. I didn't really enjoy the programming from as a job. I did it for I think 2 years. I found it to be really frustrating because I worked on the same project. Every customer that we dealt with wanted a different tweak doing, but the tweaks were not that easy because it was all driven off a database which was custom. Really did not enjoy it. So then within the same company, when the opportunity came to move on to the hardware side, I started building PCs which were sold to customers. I was a lot happier, and that kind of set me up for the rest of the time. It was quite a while before I went back to programming after doing C on the PCs. I think it was possibly Visual Basic in Windows. So there was quite a while before I did anything again. And then recently it would have been programming C on Arduino that really got me back into it. So doing this on Commodore is probably the most advanced programming that I've done in quite a while, and it's really got me back into wanting to do more programming. And I've actually started to learn 6502 machine code and assembly, which will be another video. But I think that's it. So this is on my GitHub if you want to have a look and download it and play it for yourself. And it actually plays really, really well on a real Commodore 64. So thank you for taking a look at me learning how to program and programming this Pac-Man game over the last few months. And hope you've enjoyed it. And there'll be plenty more videos coming up soon on retro computers and programming and whatnot. So thank you for watching this, and I'll see you again soon.